Here's how to use Newton's laws to solve force problems in physics. So in this example, we are given two 5-kilogram blocks that are connected by a rope. One block hangs over a massless pulley, while the other block is being pulled to the left with a force of 90 newtons. And they're asking us to find the tension in the rope. The best way to start these types of problems is by drawing force diagrams for each of the blocks. Looking at the first block, we have the force of gravity pointing down, the normal force from the ground pointing up, the pulling force to the left, and the force of tension in the rope trying to drag it back to the right. This tension in the rope pulling back can be kind of confusing, but think of it as being caused by the weight of the hanging block, making it more difficult to pull the first block to the left. If there was nothing connected to the rope, and thus the tension in the rope was zero, then it would be a lot easier to pull the first block. Now looking at the hanging block, we have the force of gravity pulling it down, and the tension in the rope pulling it up. Note that there is no normal force here, since the hanging block is in the air and not resting on any surface. The next step is to write out Newton's second law for the sum of the forces in each direction. However, before we do this, it's a good idea to come up with some rules for which way is positive and which way is negative. This is what they call a sign convention. It turns out it doesn't really matter which direction we call positive, as long as it is the same direction for each block. In this case, I like to draw an arrow for the combined movement of both blocks, since they are attached together by a rope. Here we're going to call moving counterclockwise as positive. So for the first block, this means that the left is positive and the right is negative. Looking at the hanging block, this means that up is positive and down is negative. Now we write out the sum of the forces for each block in each direction and see where the variable is that we're trying to solve for. In this case, it's the force of tension. Now we need to be clever using physics and notice that any movement in the x direction for the first block is the same movement in the y direction for the hanging block. This is because the blocks are connected by a rope and move together, which also means their acceleration will be the same. The other bit of physics we need to remember is that the force of tension from the rope is the same for each block. The only difference is that the forces point in opposite directions. This makes sense because of Newton's third law, which talks about equal and opposite forces. Using these facts, we can now rearrange the two equations for the acceleration and set them equal to each other. The last step is to do some algebra to solve for the tension in the rope, which gives us our final answer of 69.5 newtons. And there you have it. That's how to use Newton's laws to solve for force problems in physics.